Okay, this next section is where we kind of transition into similarity, and a quick theorem here at the beginning, and that is that two figures are similar if and only if the ratio of the corresponding sides are equal and corresponding angles are congruent. Okay, so let's see what we do with that. So let's take a look at problem number 1 here. And 105 is supposed to be right there. So it says that cat is similar to dog. That's the symbol for similar. So I know that there's a bunch of information here. Find as many angle measures as possible. When I write these similar, like cat and dog, that means that the corresponding angles would be C and D, A and O, T and G are the corresponding angles for those triangles. So that means if this is D, dog, then that corresponds with the C in cat, so this angle has to be the same here. The T here is 50, and that corresponds with the G, so that has to be 50 also. And then I can back into finding this angle here by subtracting from 180, 25, and this will be 25 also. Finding the length of DG, let's call that length X. So I know that I have some corresponding sides here, so I can set up ratios. So I know that, for example, 31 is to 24. As the X for DG corresponds to the CT, so it corresponds to the side that's the 11. So it's going to be X over 11 like that. Cross multiply and solve. X ends up being equal to 14.2. Okay, let's jump down to the bottom here and take a look at this problem. Some of these things here kind of messed up on my computer, but this is triangle and this is a similarity symbol right there. So I got two triangles that are similar to each other. This little triangle is going to be similar to the entire big triangle here. You're going to see a lot of this type of similarity in subsequent days and units. So ST is 3, TQ is 7, SP, which is the entire length of the blue, maybe I should use a different color there, is going to be 10. So hopefully you can see that the side that's the 3 corresponds to the side that's the 10, so I can set up any, this is X right here, I can set this up as 3 is to 10, so 3 from the smaller triangle is to 10 from the bigger triangle, as 7 is from the smaller triangle is to X of the bigger triangle. You just have to basically line up, these are both from the smaller one, and these are both from the bigger triangles. Okay, I could have also written it as 3 is to 7, as 10 is to X. And hopefully you can see that these are exactly the same thing. Basically, all I've done in the case of the second one is I've just flipped the 7 and the 10. It doesn't really matter because I'm going to multiply. When I cross multiply, I'm going to multiply the 7 times 10, which is the same thing as 10 times 7. X, by the way, ends up being equal to 23 and 1/3. Okay, let's flip over to the next page. Okay, so on the next page here, let's take a look at number 4. Triangle ABC is similar to triangle DEF. And I've got a bunch of stuff going on here. And hopefully you can see that I have X's and Y's. So I'm probably looking at solving a system of 2 equations since I have 2 variables. 2 variables, 2 equations, 3 variables, 3 equations, 1 variable, 1 equation I need. So I can definitely say that from the measure of angle A, 50 is going to be equal to the measure of angle D, right? Because those are corresponding angles. So 2x plus 5y. There's one equation. The second equation, it looks like I know that B, and I know, let's see, I know A, I know B, and I know C because C is the same thing as F. And if I take all three of those and add them up, I should end up with 180 degrees. So 50 plus 5x plus y plus 102 minus x should be equal to 180 degrees. There's my two equations. Solve the system. I think you can simplify this second part. You can simplify to something nice and easy like x plus y equals 13. Solve the system. You end up getting an angle F there equal to 33. Okay, so go ahead and try that on your own. And let's jump all the way down to the bottom. Let's try this because this ends up being a very common type of problem here. So I need a little diagram here. I got a sunny day. Notice this is shadow. So here's Caden. That's our older son's name, by the way. Notice there's a shadow of 8. Okay, so there's his shadow. And notice there's a shadow of a nearby tree is 24 feet long. So it's always going to work out like this. So you have a tree. Let's demonstrate my awesome drawing abilities here. And here's where the sun belongs, like up here. It's shining down that way. And it's always going to end up being some sort of triangle within a triangle like this. That type of figure there. Okay, where in this case this is 8 down here, and then the entire length of the bottom shadow is going to be 24 like that. So this down here would have been 24. I know what this one is right here. It's 5 feet 10 inches tall, which is exactly how tall he is. So I'm going to put this in terms of feet. So it's 5.83 feet. 83 coming from 10 divided by 12. And what I'm looking for is the height of the tree, x. So x right there. So in this case here, you're going to end up with similar triangles. You're going to end up with a triangle that's right here being similar to this bigger triangle right there. Okay, and you can go ahead and write a proportion. It'll be x is to 24 as 5.83 repeating is to 8, and then solve for x. X here will end up being equal to 17.5 feet. Okay, that's it for the problems in this section. The problems aren't that bad in this section. Hopefully you'll find it to be pretty easy. So give it a try. All right, good luck.